Barnes. I am with KNX UK. We're a non-profit trade association, and we're here to tell you all about not just KNX, but what it can do for you. Today's seminar is all about how to achieve a home for life and make your home adapt to you. I'm joined today by Paul Folkes. Would you like to tell us a bit about yourself, Paul?
Good. Oh, blimey, crikey. Afternoon. I'm the KNX business manager for Tabin UK. Tabin is a German manufacturer of products. I'm also the co-chair of the KNX UK Association as well.
And also by Paul Doyle, who is an independent consultant. Paul, tell us a bit about yourself.
Hello everybody, my name is Paul Doyle. I'm an assistive technology consultant and originally an electrician and then an electrical engineer working for the NHS, providing accessible solutions for individuals with physical, sensory and cognitive disabilities. And more recently I've been an independent consultant providing assistive technologies for individuals who want to live independently.
And finally, Martin Hawley, last but not least by any means. Tell us a bit about yourself.
Hello, I'm Martin from Young UK. We're a design-led switch and socket manufacturer working in both conventional 230 volt and also in the KNX world as well for adapted living.
So today's seminar is split into three main sections to make it make a little bit more sense. The first one is about how to achieve a home for life. Paul Folkes, you were going to tell us a bit about the background and your interest in assistive living.
Thanks, Tracy. Achieving a home for life, what are you actually looking for? What you've got to do is you've got to identify your long-term goals. So you've got to look at who is the building being designed for, what that building is going to be used, used for. Is it a starter home? Is it aimed at retirement home? Is it within a community? Is it standalone? All of these will affect the needed design. So these are sort of your basic design criteria that you want to be looking for. So homes for life, you've got to look at different use profiles within that design as well. So the requirements for a single person are going to be considerably different than a requirement for a family of 4 people. You're also going to have a different requirement if you've got a family with a disabled child or you're disabled yourself. So these need to be thought about that design right from day one, which we'll sort of come on to. Also, you've got to think about the potential for change of use as well. So what you need out of a house when you're 30 or 25 years old is considerably different from what you're going to need at 55, 65 years old. These are elements that need to be thought about within the house design. One size does not fit all. But these are long-term goals. Now, we seem to think of houses as an element that is just passing through our lives, but actually a house is going to stand for probably at least 100 years. The housing stock in UK is considerably older than that. So we will be cutting ourselves short or doing ourselves a disfavour if we're not thinking about this at the design point. And thinking about this at the design point, thinking about this at the design point is a day one objective. You can't design a house, build the house, and then go, yeah, now what do I need this house to do? What do I need to put into this house? You've got to be thinking from day one about things like your cabling requirements, your services, your ventilation, your water, your waste. This all needs to be thought about from day one. Now, one of the things we're looking at here is Homes for Life and the effect of smart wiring. I don't like the phrase smart, but it ticks the box at the moment. So we think about waste and grey water and stuff like that, but we also need to be thinking about wiring. We need to be thinking beyond the basic wiring regulations. On larger projects, we'll often use an M&E consultant, mechanical and electrical. Actually, what we should be doing is thinking about an M&E and a C, a controls engineer, a controls integrator within that market as well, within that sector. We need to be thinking about controls of all of the elements within the building: heating, ventilation, light, glazing, all of these need to be assessed from day one. And they need to be assessed by someone that has an overarching viewpoint of it. They're not looking at one particular specific system. Do we have any quantity surveyors in the audience? You know, okay, I'm assuming you're not going to put your hand up in the air if you are. Quantity surveyors will look at each individual aspect of a building, and what that means is that at the tender processes they get broken down and they get individualized, and you end up with disparate systems within a building. With a controls integrator or a controls engineer overseeing this, then this can be avoided. You end up with a building that flows much, much better. A constantly evolving situation. So why have I put that as constantly evolving? Why? What is that to do about a house? Surely you build a house and then that's it. Absolutely not. If you're doing that, if you're thinking of a building in that way straight away, then you're already thinking about, you're not thinking about a home for life or a building for life. You're thinking about a building for one specific point in time. And that means that it values the level of that building. So you need to design, we need to design for the future, regardless of what that future is. If the front end interface, so that's that bit on the wall maybe, where you interact with your heating system or with your lighting system, needs to be changed. And it can be changed for any reason at all. It might just be that the owner wants to change the decor or change the way that they interact. But it might be because they need to interact with it in a different way. But that needs to be done without affecting the functionality, the core functionality of what it's doing of that building. What I'm talking about here about the design stage is that the planning stage needs to reflect the here and now. That, you know, I'm not trying to step away from that, but we've also got to look at the design stage of beyond the here and now, what it's going to be doing, not in 5 years' time, but what's going to be happening in that building in 25 years' time. That future use of that building could change. Not only for yourself that's in the building, or the user of that building, the resident of that building, but also if that resident changes. You know, say it will change from a single person to a disabled person to a family or to whatever level it happens to be. The building needs to be able to adapt to each of those user needs. We're going to be talking a little bit later about the assisted technology aspect of that, and that's what Paul Doyle's going to be talking about. So I'm not going to touch on that. But what it does mean is that we need to be thinking about changes, not just in lifestyle, but changes that might happen to the person. And so that's what Paul's going to be talking about. I just want to touch also on the grid supply question. You'll see this a lot around here about everything from battery storage through to microgrids, community energy systems. These should all be being planned into a building. Our building should be future ready for these. We are designing that home or designing that building for future use. It's not a case, we can't just strip out the wiring and put in completely new. We've got to be ready for that now in the houses that we build right now. Now, unfortunately, within the volume building market in the UK, volume house building market in the UK, it is built to the lowest possible common denominator, which generally seems to be cost to that particular developer. And they build to the lowest quality. Now, one of the things that, you know, I've been talking about recently is that we don't buy anything else like this in our lives in this particular fashion. The house is going to be the biggest purchase you're going to make in your lifetime, and a number of those buildings. And it costs a huge sum of money. When you go out and buy a car, you spend, you're going to spend, say, £70,000 on your new Audi. It's not a one-star NCAP rating. Audi doesn't say, we've just passed the minimal amount of regulation that we can possibly do, and here's our new car. But that's how we build, and that's how we sell houses. We've put the minimal amount of insulation in. We've put the minimal amount of technology in. This is what we can get away with to supply you with a house that you're going to pay, well, what, £500,000, £600,000 for. That's not a sustainable build route in any way, shape, or form. So I just want to finish on this last quote here, which I will have to read. I'll read it from the screen, actually. Now, we're in the third decade of the 21st century. So is this something new? Is this something that we're just talking about now? Now, if you look at this, this is a quote from Rowe in 1991. If you want to get the actual quote from me, speak to me and I can give you the reference for it. So this is in 1991. In our anxiety to leave the housing market as free as possible, we allow short-term costs to dominate our policies. Every year we add to the country's housing stock, dwelling whose inflexibility makes them even less suitable for any but the young and agile. Now that was identified in 1991. Why has it not changed beyond that? We need to think about that. We need to be building better and building homes where we're thinking about their future use, and the homes for life is absolutely key and core to this. So, thanks very much.
So, Paul Doyle, you've got some experience in this area. We do need to move on in a moment, but did you have some comments on what Paul's just said?
Well, I agree with everything that Paul has said, naturally, but I think one of the shocking things that I find, I tend to work at the other end of the scale. I tend to work with people with very chronic and severe accessibility, cognitive and physical needs. And when homes are built by M&E consultants for people with very special needs, how they interact with their physical environment using technology is always the last thing that they attend to. We literally get to a point where sometimes somebody's going into their home in their wheelchair, and the question they ask the person who's handing over the property to them is, how do I open the door? Because when we look at building standards in terms of accessibility, we're looking at the physical environment. We're not looking at the sort of the electrotechnical environment. So somebody wanting to control their heating, their lighting, their ventilation, they are not going to be able to go up to a standard wall panel and do that, because they have a physical disability. So many of the people that I work with have spinal cord injuries, so they have no upper or lower limb mobility. So the fanciest control panel in the world is no good to them. It might as well be a brick. So how does one interface with that? Because we have an aging society, everybody's needs are going to change. You're absolutely right. Now, as I said, I tend to work at the more extreme end of the spectrum, but as people age, as people become less mobile, as people spend more and more times in their homes when they retire, they need to be able to inhabit an environment that works for them.
It's the level of flexibility that we can do. We can build into our houses right now, and that's what sort of seems to be being missed out at that design stage. The key thing that I've always is that it's a day one decision. It's not build a house and then let's see how we can change it. How we can put this in, this smartness or this flexibility in at a later date. It's about doing it right now.
Are there any electrical contractors or electricians in the audience? No? I like a little anecdote. When I was working in the specialist college, we needed to refurbish some buildings, and we had 230 volts running down the wall. Because that's a light switch is. The supply is 230. And we had lots and lots of people with very special needs, many on the autistic and learning disabled spectrum, for whom 230 volts was a magnet. They would want to pull that plate off and they would want to fiddle with it and put themselves in a place of danger. And it was an absolute nightmare trying to convince the electrical installation guys that we were going to move away from 230 and use safety extra low voltage in an environment that meant that these people could pull those things off till their heart's content, but not put themselves in a place of danger. We need to start shifting that paradigm because spaces are not flexible. They haven't been flexible since 1910 when the first IEE regulations came out. We need to think about properties that are fit for the 21st century.
That's great. Thank you, Paul. Paul, you're going to tell us a bit more about how you put this in context and how it fits in with industry.
Yes, sorry. As I said, I tend to work very much at the end of the spectrum. However, in fact, most of what I'm going to talk about now has an application within standard living and equally living for people who are reaching points in their lives where their hair's getting a little bit greyer and maybe not as flexible as they used to be. So I think Paul actually alluded to the first point that I'm going to make, which is getting the backbone right. And I suppose I was touching upon that in the previous sort of statements that I was making, we still install 230 volts into people's homes. We still install ring mains and 3-plate wiring systems, and once they're installed, that's all they can do. A light switch on the wall stays as a light switch on the wall. You know, if you're really going to push the envelope, you might have a dimmer on the end of it. So as a person's needs change, you know, these things, you know, the building is going to be quite inflexible. So we need to get the backbone right. And I think it's more pressing or more prescient now than it's ever been, because before I came to this stand here, I was having a wander around, and a lot of the presentations today are talking about our needs to conserve energy, our needs to create environments that are energy efficient, and working with sort of the right backbone. It's my belief, and I stand to be corrected. If anybody wants to disavow me of my opinion, I'm more than happy to do so. It's my belief that if you get the backbone right, you can create environments that are not only more accessible for individuals with special needs, individuals who are getting older, but you're also creating environments that can manage and maintain and create sustainable environments too. Because the KNX backbone will enable you, or one, to turn the heating on and off, open and close the doors, windows, curtains, all that sort of stuff that traditional smart technologies do. But those features would also be transferable into a space where you can start controlling the heating when rooms are empty. So if you're no longer in that space, if you can detect that there's nobody in there, you can drop the temperature. And I think it's more pressing now, as I say, as we're reaching the energy crisis that we're already in, that people who are disabled, people who are older, tend not to be in employment. And that's just a fact. So therefore, they spend more and more time in their homes. So they are net consumers of energy, net consumers of heat, because they basically need to keep themselves warm in the winter. So this notion that we can provide an accessible environment, but also manage and maintain energy consumption, I think it's a bit of a no-brainer. So if we get the backbone right, we can deliver two levels of functionality, sustainability and accessibility, using one feature. Now, I've been using the KNX system for about 25 years, initially as the EIB, but more recently as KNX. And I must say, I am not an employee of the KNX Association. I have no affiliation to the KNX range of manufacturers. I'm going to be shot now. But it's the right tool for the right job at the moment. When and if something comes along that's better, I will use it. So when I'm specifying a property for an individual with, say, an acquired brain injury or a spinal cord injury, this is my go-to technology at the moment. Now, you may not necessarily like these, but that's the way it is as we are. However, so one of the other things that Paul mentioned was the notion that the property should work for somebody. Does anybody know an architect called Corbusier? A famous French architect? Yep. And one of his famous statements was a T-shirt where he says, "A home is a machine for living in." And I always thought that was a bit of an arty-farty, airy-fairy sort of statement. But the reality is absolutely borne out in that statement. It's an environment that should facilitate a person's living habit. Yeah, it should keep them safe, it should keep them warm, it should keep them it should enable them to function independently as best they can. So that notion, when I'm working with clients who are thinking about building a new property, one of the questions I ask them is, how is this property going to work for me? Because we don't tend to ask that. We just tend to walk into a building that's been completed for us. But if you're in a position whereby you're building your forever home, and that could be a person who sustained an injury, had a medical settlement, and now have got a couple of £1 million to build a property, what they need to ask their architect, their M&E consultant, their property developer is, how is this building going to work for me? How is it going to keep me safe? How is it going to keep me secure? How is it going to enable me to live independently as best as I can? And how is it going to save me money? How is it going to be energy efficient? And so all of those issues are particularly sort of prescient in the smart home community. This isn't rocket science. I'm not introducing any new concepts. And I think when we were talking about putting these things into context, an older person, a person with a disability, or a young family, they all have these same desires. Only thing that changes is how those desires are expressed. So when we look at things like safety, security, comfort, and convenience, these are terms that are bandied around in the smart home community every day. There's nothing particularly novel about that. However, putting it in the right context, so safety from a an electrical contrast perspective might be fire safety. The enclosures that we're using are now metal and will retain a fire should it catch fire. Safety from an assistive technology perspective is how am I going to turn the lights on and off when I can't physically reach that. How am I going to reach that switch, turn it on, because I'm a little bit unsteady on my feet, I might fall over and injure myself. So can my environment enhance my safety? Likewise, can I tell somebody that I'm in trouble? There's a term there, telecare. We're developing technologies that are bus-based. And a bus is just basically a pair of wires down which signals are sent. So if we can monitor those signals, if we can see when somebody's turning the lights on, if we can see when somebody's turning the kettle on, then we can use that information to monitor somebody's health and well-being. So if it's an older person who's vulnerable, if they have a daily routine, they get up at 7 o'clock, they go to the bathroom, they put the kettle on at 7:30. If we can create a model of that individual's behaviours using off-the-shelf technologies, when that model is contravened, when an adverse incident happens, if that person doesn't get out of bed until 3 o'clock in the afternoon, then that might be a problem. These are technologies that you can use this technology, and it's already freely available. There's no rocket science here, and I think one of the things I would like to sort of leave you as an audience is that none of this technology is new. None of these needs are new. The only thing that I think we're proposing is that we're stitching different items, different functionalities together in a slightly different manner. Likewise, with security, one of the things we're talking about now is energy security. So if you're a person who's vulnerable, obviously, if you lose the connection to your energy, then you may not be able to open and close the doors, get out of a building in the case of an adverse incident. So all of these things are features and not context. They're features that we're already familiar with. And I think as one of the things I like to sort of describe from my perspective is the journey of the individual. So we all start out as consumers. If we're lucky enough to live to a ripe and healthy age, we might then become what we call service users. We require services from health and social care providers. And equally, at one point, we might become patients. So this is a journey that I think people will make along their lifespan. So you start off consumer, service user, patient. More recently, the Department of Health are now starting to look at the notion of hospital at home. Has anybody heard of that phrase? So people are being treated in their own home environment. So the things like safety, security, comfort and convenience, these are concepts that would be particularly important for somebody who's in the home patient context. If they're unable to reach the front door because they're bedbound or going through treatment, then using smart home technologies, they might be able to talk wirelessly to the front door using a Ring doorbell or using some other kind of communication technology and control that environment. So assisted living is not a completely divorced aspect of designing, building and implementing a home. Assisted living is one element of a spectrum. And as I said, I started out working with the very, very acute need of individuals, but all of these issues that we're talking about have an application to people who are older, people who have mobility impaired. And remember, some people will be temporarily impaired. If you break a leg, if you have an operation, if there are periods of time, if you're heavily pregnant, if you're carrying a child, you will be, mobility impaired at that point. And whether that's a permanent mobility impairment or a temporary one, a property that can meet your needs is absolutely valuable. And so, I suppose this particular slide is speaking about the next phases. How do we get industry to understand why we should be doing what I'm proposing, why we should be enabling people to have properties that will adapt and change to meet their needs throughout the life course. And I think the constituency we need to start basically lobbying and influencing are the installers, because they don't know this technology exists in this manner. They know the technology like KNX exists, but they don't know about the applications. Likewise, the integrators, they know how to create very smart and immersive environments, but are they creating enabling environments? And there are no assessors. I work as an assessor, an independent assessor. My technical role is a medical technical officer, as was, but I'm now called a clinical technologist. That's my trade name. And there are 300 of us in the UK. So we're not rolling out a massive rollout of assisted and independent living with 300 pods like me. So we need to start building more assessors. From a wider policy context, just to give a bit of background, the International Standards Organization are putting together standards for assisted living and assisted living communities. So this is something that's happening in the background. Anybody familiar with Part M, building regs? There has been a consultation recently about expanding Part M. Part M is effectively the building standards for accessible buildings, and I think subsection 3 is about wheelchair buildings. Now, at the moment, they've only got a very, very limited scope in terms of what goes into a physical building in terms of wiring. I know the Part M consultation was about putting the cable management systems in for more intelligent and more accessible buildings. But that's it's a finger crossed sort of thing. We're hoping that that's going to happen in the next few years. And if you're interested in smart homes and the assisted living context and sustainability, there's an all-party parliamentary group called from Policy Connect, and they've created a report that contains pretty much my presentation today, a discussion about why properties, they need to be more accessible, they need to be more energy efficient, and why we should be doing this for people, both younger people, older people, and people with disabilities.
Thank you very much. Guys, did you have anything else to say about that to Paul?
I think the only thing I want to pick up on is what Paul was saying, is that this isn't new technology. This is not something that has just come along in the last 3 or 4 years that we're talking about. The KNX protocol has been around for 33 years. I've been doing builds like this and installs like this for over 20 years. But the whole point is that the technology, is that all of this stuff is there. It's very simple. It's very, very effective. It's not internet dependent. You're not talking about having to have, what are we on, 6G, heading towards 6G. It doesn't need any of that. It does not need this. You're talking about building automation at a very, very simple level. It needs to switch a light on, do some heating, but then that layering up, as Paul said, that layering up of enablement, you are still using the same core infrastructure, and that's the absolute key. That is the thing that's going to bring the cost dramatically down. You're not talking about bolting something on at a later date. All you're talking about is maybe changing some part of the commissioning, some part of what would be classically called the programming. But it's simple, it's effective, and it's just been there for so long.
Sorry, to underpin that, one of the things I did miss was that when we start looking at building that layered approach, and one of the reasons why I chose a distributed intelligence system, KNX is built up of nodes rather than a central control system. One of the reasons why we use that is that you can lose a node. So when I was talking about youngsters messing around with systems, if they want to damage a piece of the actual system itself, we can lose that, but the system remains functional. And the one thing that's required for an assisted living domain really is that we need to maintain that functionality. So you're absolutely right. If you lose that internet connectivity, the building still needs to behave like a building. So if you've got some form of additional control or infrared controller that's built into a wheelchair controller, a communication aid, or a traditional environmental control, the person can still control their building when they've lost all connectivity. And that sort of like intrinsic safety is something that draws me repeatedly back to the KNX protocol.
And that's the distributed intelligence that KNX brings into the project, right? So the node that you're talking about could be a 4-channel dimming actuator that could break. All we lose is that 4 channels of dimming. We don't lose all the heating control, all the other lighting control that may be in place, or the underfloor heating. So the client may be sat in the dark in one room, but they can quite happily move into another room and experience the light that they require or the heating that they require in another area.
Thank you. Martin, I think you were going to talk a little bit more about design, not just from an aesthetic point of view, but how it all fits together for us.
Absolutely. We've talked quite a bit today in both sections about the actual wiring of a building. It's fundamentally really important to design the building for the future use. Paul made a comment a short moment ago, and I just want to elaborate on that point as well, that the fact is you can design a system with the basic amount of functionality today. So if your budget doesn't allow for all the fancy stuff to go onto your system, and all today you can afford is the lighting control, then we can add heating control on later on. We can add the blind control later on, as long as we've done the design right in the first place and we've enabled the cabling to be correct and we've put that wiring schematic in place. We can just keep adding to that system as time goes on. So the designing of the system and the architecture of the building can make a massive change in the way in which the client can add and develop and change the way that we are through our life cycle. We talked about designing buildings for the able-bodied and the non-able-bodied people, and the way in which that we develop and change the system and whether we're using voice activation. We said that KNX is 38 years old in design, but I can take products from today and put it on a 38-year-old system without any upgrading. Just 2 new products, and that system then becomes completely up to date, which is a massive strength. We're not changing huge servers and the infrastructure of buildings and ripping out thousands of pounds worth of wiring just so that we can update a system. We're just changing the technology that goes on. And it may be the design of a switch that the client moves in and doesn't like the young switch that's on the wall and they want it to be a different switch. Then we just remove the connectors and change that design that the client is using. It could be the visualization system, the way in which we're using an on-wall display or whether we're using a switch to control it. It may be that it's really important that we start using things like voice activation control. Maybe we don't have the dexterity to be able to push a button, but we do have the capabilities of speaking to Alexa or to Siri or to Google or to Pro KNX, Skimps, or whoever it may be. KNX in its open protocol means that we have the flexibility of over 500 manufacturers, and I can say that sitting here as young today. There's 500 manufacturers that you can choose from to design systems that work to the best of its capability for the building. It's about building buildings that work to their best. So it could be the lighting control or the heating control, the wet or dry underfloor, the irrigation control. It doesn't really matter what you want to control. KNX controls it in a up, down, on, off or percentage route. Anything mechanical or electrical can be designed into this. We're taking quite a unique approach. We're making mechanical and electrical talk to each other. We're not one part of that specification, and which is why it's so difficult when it comes down to the quantity surveyor, because he can't break it up and go, well, actually, this is going into the electrical budget. We're both. We have one thermostat calling for a temperature. We don't get an energy consumption like this because we've got an air conditioning controller and an underfloor heating controller and a radiator controller all trying to call for temperature at the same time. The design of the system really comes into play when you start talking about how the client is going to interface with it. Could you just go back one slide for me? Because I'm jumping all over the place. Just one forward. Sorry. So the switch that you see on the wall there is a switch by Young, but the importance of this is enabling the clients to have a simple user interface. It's very easy to understand of what's going on. We've got blinds up, blinds down, temperature up, temperature down. I talk about the temperature because this is really important, because as I said just a minute ago, we're actually just calling for a temperature. The BMS system is actually working out what needs to happen. The client doesn't care whether the air conditioning's going or the underfloor heating. They want to be at 23 degrees. So what temperature is the room? We take multiple temperatures to give true heating control. We can do time-based scenes. We can add PIRs into place, so we can do logic algorithms to work out what happens based upon a section. So I walk into the bathroom, the lights come on. I've been in more than 5 minutes, the extractor fan comes on. The demystifying mirror can turn on. I've been more than 10 minutes and the towel rail turns on. But as I leave that bathroom, fundamentally the most important thing is the light switch is off. Then a course of action will happen. So, for example, the demystifying mirror will turn off. The extractor fan will run for the 11 minutes it has to by law. But the towel rail will stay on for an hour. so my towel's nice and dry for the next time I come in. But in a conventional system, you'll have that towel rail running for all the time that the heating system's on. So we start making a demand-led system. It's a simple system working on parameter setting, enabling the design and the aesthetics to come in harmony and make things as simple to use as possible. It removes what we call wall acne. Rather than having lots of different switches controlling lots of different elements, on the wall we have one switch controlling every single device function of the building. We have matching sockets and matching switches, and they come in and really start enabling us to maybe in an assisted living world determine different floors in buildings. So we could have red sockets on the ground floor, blue sockets on the second floor. And for that we use the Le Corbusier, which we've already mentioned today. And we can start bringing in the design-led solutions from him within our ranges. There's some real fun to be had as well with these systems. It's not just get the geek out, right? But we can get the geek out. We can add a weather station onto the roof. And we can track the sun's movement, so we can keep solar gain in or solar gain out, depending on whether we want to heat or cool the building. We can start treating window treatments as part of the building to help with that energy management. The more and more the day goes on, we're now being charged more and more for our energy consumption. And if we don't take the responsibility on designing systems that are more energy mindful, then we're just going to be in more and more trouble as time goes on. By adding all of these systems together on a truly holistic approach, we start managing the way in which the buildings output the energy consumption. It could be that we're pulling in solar energy, or it could be thermal energy. Whatever we're trying to achieve can all be managed by using weather stations and window treatments and thermostats and zonal heating control. Now you may move on.
That's brilliant. Thank you, Martin. So just really going out to the audience, whether you've got any questions. Guys, whether you've got any comments to Martin.
Yeah, I have. Just picking up on that, the solar or the solar shading is. Are people aware of the new Part O that came in June last year for overheating? If you actually read that, and unfortunately I have, which is really, really a sad reflection of my life, but and it's a very, very dry document. But one of the sort of key elements that it boils down to is that it says that to reduce overheating is that to reduce your window size. Now the major house builders love this because they can put even smaller and smaller windows in and get away with it because they're building to the building regulations. So eventually we're going to end up with like little windows like this just to do it. But there is one paragraph in there, I can't remember it exactly, but it says that there are alternative approaches available. The alternative approach, if you've got a large glazed section, especially if it's south facing, is to use dynamic shading. Now dynamic shading, it is not just putting out a brise soleil or just having blinds in, but as what Martin said, it's talking about tracking the sun. Your system will know where your house is on the planet. It knows exactly where the sun is at every single time of the day throughout the entire year. It will also then be layered up with, is the sun out anyway? So you will get your lux reading as well. But it will also be looking at your interior temperature and your exterior temperature, and if your underfloor heating is working. So it's more than one system. You will only get this level of control if you fit an integrated system. If you fit systems that do not talk to each other, it's going to fall apart. It will not work. So that idea of integration, one core infrastructure and one protocol, which is sort of what we're talking about today. Get it in from the start,
I just wanted to say, underpin what Paul and Martin have said. The clients that I work with, they don't want technology. They want outcomes. They want a house. If they're a wheelchair user and perhaps they want the room temperature to be around about 23 degrees, maybe they're not moving around as much as they used to. They want that house to stay at 23 degrees 365 days a year. How the technology delivers that is irrelevant. What they want is they want to be comfortable living in their homes. And outcomes are what I deliver, and technology is what helps me deliver those outcomes.
Absolutely. I mean, and simplicity in design also comes with the simplicity of aesthetics of a switch. A lot of clients just want to walk in and turn a light on and turn a light off. But what that on and off button actually controls in the background is what is massively important. So to a client, they're just turning a light on and off. But actually with the BMS system, that could be controlling the light level depending on what time of the day is. It could be bringing blinds up or blinds down depending on the time scale of the day. We could be using the circadian rhythm in a basement or a swimming pool area to start bringing the colour in. Well, you talked about it earlier on with home assisted. And when we're actually in a bed and we're unable to move from that bed, using circadian rhythm, human-centric lighting, we can actually mimic the daylight so that we can start making and helping with people sleeping at the right time of day. And that's just all part of what a BMS system, a lighting control solution, no matter what it is doing. And it massively is your responsibility and our responsibility to start building homes that are more mindful in the energy consumption that we use.
Fantastic. Anybody got any questions? No? So one that quite often comes up is cost. So, how long is a piece of string? But what comments do you have about cost for this sort of technology?
We obviously get asked these questions all the time. How much does this system cost to put in? And it's a fair question because everyone wants to know that cost. Everyone's talking about return on investment. But the key thing is to look at it not as an individual or standalone cost, but as a cost as part of that build. If you're going to, let's say you're building a house or your own house, or you are planning your own houses, you don't look at it as a standalone cost. You look at it as part of that total build cost. To build a house is going to cost, not including the purchase of the land, is going to cost around about £100,000 for a simple house. So if you're talking the difference between £1,500 to put your wiring in, or you're talking £3,000 or £4,000 to put your wiring in, when the reality of putting that into your total build cost that's when it becomes relative. So it's relative to what you're paying out for the entire build, not saying, it's gone up from £1,500 to £4,000. That's not the point. And then you have to look at the long-term cost. You have to look at those energy savings. All of a sudden, people are going like, it would really be good if I could save 10% or 15% on my energy bill. But imagine saving 15% on your energy bill every single day or every single year for the next 5, 10, 15 or 20 years. All of a sudden, an investment of £3,000 is, that's nothing. That's what I should be doing. And it's happening all the time. You are getting those savings all the time. So, yes, there is a cost element, but there's also a cost element to buying a car or, going on holiday. No one asks, what's the return on investment on a holiday? And we shouldn't be looking at having to have everything at what that specific cost is and to be repaid back over a certain amount of time. It will repay, but we're talking about comfort. We're talking about this homes for life beyond what's going to be happening in the next 24 months.
A huge housing stock at the moment. Can we retrofit any of this back into what we already have?
Yeah, I've just moved. I used to live in Leamington, and I lived in a house that was built in the 1890s, and I fitted KNX into that. And my energy bill it was a 3-bedroomed detached house, say with solid brick walls. My energy bills for 6 years were less than £1,000 a year for all of my energy. I've just moved down to North Devon. We've got a fisherman's cottage that's 1670, I think it's built. I'm putting KNX into that. So yes, you can. It's not specifically designed though for the retrofit market. It's not a retrofit per se, but you can. It can be done.
When I've worked with clients who've had their properties adapted, so they still live in their own home after they've had a catastrophic incident, ordinarily what will happen then is there'll be some degree of structural work done. If they're living downstairs, they might need a wet room or a downstairs bedroom. It's very easy at that point, when you're rewiring to put KNX in. Very, very easy. But you're absolutely right. It's not necessarily designed specifically as a retrofit solution, but if you've got the right opportunity, i.e. being a major refurbishment, then it will fit in really easily.
And we have RF solutions as well. So areas that we can't get cable to, we have KNX RF to enable that. So we were talking about glass facades earlier on. If the client is absolutely adamant they want to switch in the middle of the glass facade, then we put a KNX RF switch in, because there's no way the client's going to approve a green cable running up a piece of glass. The old housing stock is actually a really poignant point, because we don't utilise what we've got. We want to build new, but actually on that old housing stock, the likelihood is the cabling's going to be old, so you're going to be refitting anyway. I bought a 1969 house and I had to completely rewire that, and you can just put the wires back to a central location. It enables you to adapt that building throughout the rest of the life cycle of that building.
It is, if you just think back to that row quote that I used, it's dealing with the existing housing stock is really, really important on all levels. We should be looking at fabric first on the existing housing stock. But the thing is, we've got to be, and that was from 1991, but we are still building houses that are rubbish, basically. They are, it's as simple as that. They are cheap and nasty, and we have to stop doing that. So yes, let's look at the existing housing stock, but let's stop building houses that are going to become that rubbish housing stock.
One of the things about existing housing stock is that old people live in old houses. Yeah, and these are the people that possibly would benefit from some degree of integrated control technology, because they'll need to keep those houses as warm, as cost effectively as they can do, and they'll probably need the functionality of a smart environment as they are older, and they probably have some form of age-related condition. So they'll get somebody in, they'll bang in an old wiring system, and they'll have absolutely no more functionality for what is effectively a significant investment.
Thanks, guys. We are now out of time, I'm afraid. If you'd like to hear more from the guys, we're literally 2 stands along, just over there. Come and see them. It's such a huge subject. Thank you for listening. If anybody needs CPD points, we can do those for you as well. But just for now, thank you very much. Thank you, guys.
Thank you.
Thank you.
Thank you.